Hello, folks. Welcome to the start of the last chapter of the school year. What? So awesome. Here we go. We're going to dive right in. This chapter is on something called sequences and series. So understanding these concepts is going to prove to be a really important foundation, especially for those of you that are going into calculus next, whether that be next year here at GP or whether that be in college. The ideas here are really the start of calculus concepts. So you've heard of these words before, and you probably have your preconceived notions about what a mathematical sequence might be, more than a series, probably so. So here's an example. An example of arithmetic sequence. We'll start with that one. So an example of an arithmetic sequence would be something like negative 23, comma negative 12, negative 1, 10, and then we can fill in the blank here for a few more. So basically a sequence, arithmetic sequence, is a list of numbers where we could figure out the pattern by taking just the difference between our terms. Right? So if I want to figure, okay, how did I get from negative 3 to negative 12? Well, I added 11. Same thing. Negative 12 to negative 1, I added 11. Negative 1 to 10, I add 11. So then 10 plus 11 is 21. 21 plus 11 is 32. And 32 plus 11 is 43. And so on with the pattern repeat. So basically, D is what we call the common difference. D is the common difference. That's the variable that we use for the common difference between successive terms in the sequence. The common difference between successive terms in the sequence. And so in the last problem, D would equal 11 because the difference in each one of those terms was positive 11. You added 11 each time. So in general, with an arithmetic sequence, it basically has this, this is not a formula, but this is how any arithmetic sequence can be represented. I'll say that. So you have your first term, which would be a sub 1. To get the second term, you would take that first term and you would add your common difference to it. So that would be the second term. To get the third term, you would take your first term, but you would add 2 times the common difference to it. And then your fourth term would be a sub 1 plus 3 times the common difference. And this would just continue. And of course, like, yes, this is technically A1, A2, A3, A4, and each one of these is the term before it plus the common difference. But basically where things get tricky is when we aren't able to look at a sequence from its beginning, right? If I just know the middle of a sequence, or I ask you for a ridiculous number of the sequence, you know, if I ask you in this pattern up here, like, okay, if this pattern continues, what would the 100th term be of this sequence? You know, writing out 100 terms would take a ton of time. So if we have a way to represent each of the terms by using our starting term and the common difference, then we can use that to solve for anything. So let's do an example. Very just straightforward example. So just going to be find the next 3 terms. Find the next 3 terms in each sequence. Find the next 3 terms in each sequence. First one, the first term is r minus 4, r minus 1, r plus 2, and then we're going to find the next 3. And the second example will be negative 5, 7, 19, and then we'll find the next 3. So these are going to be pretty simple because you just need to figure out what the common difference is to get from one to the other, and then apply that to the previous term. So for example, A, I got r minus 4, r minus 1, r plus 2. Obviously, I have an r no matter what. So like every single one of these terms starts with an r. And then the second number comes from adding 3. Right? Negative 4 plus 3 is negative 1. Negative 1 plus 3 is 2. 2 plus 3 is 5. So that third or fourth term will be r plus 5. Plus 3 would be r plus 8. Plus 3 would be r plus 11. In the second sequence, common difference would be 12, right? Negative 5 plus 12 is 7. 7 plus 12 is 19. 19 plus 12 is 31. Plus 12 is 43. Plus 12 is 55. And of course, these, can continue even though I ask just for the next 3. And again, it's pretty easy. You find your difference, you apply it to the term in front of it. But basically, like I've asked you earlier, what if I asked you to find, the 100th term or predict what would the 577th term be if the pattern continued? It doesn't make sense for us to write the entire list of 500 in, I forgot what number I just said, terms, right? That would take forever. So basically, this formula that I'm about to show you is how to find the nth term, which is just any number you want, of an arithmetic sequence. How to find an nth term of an arithmetic sequence. So this is one of the first big takeaways from today. A sub n is equal to a sub 1 plus n minus 1 times d, where a sub 1 is the first term of your sequence. D is the common difference. And of course, n is just the number of the term that you're looking for. So the nth term, if I want you to find the 10th term, that would be a sub 10. Okay, so this is the formula for the nth term of an arithmetic sequence. So for example, I want you to find the 41st term in the sequence given by 11, 4, negative 3. So again, I don't want to discredit problem solving. Y'all could easily figure this out. You would just continue writing this pattern, which the pattern seems to be. So to get from 11 to 4, we're subtracting 7, right? And then 4 minus 7 gets you negative 3. So I could just keep subtracting 7 from all of my numbers until I've done it 41 times. Or I can follow the formula that we just circled up there in green. A sub 41 would equal a sub 1, which is the first term. The first term in my sequence is 11. So that'll be 11 plus 41 minus 1, right? That's n minus 1, times the common difference. Now, you got to pay very close attention to the signs. If our numbers are increasing, then we are adding, so d should be positive. If they're decreasing, then we're subtracting, so our difference is going to be negative. So in this case, d, which we already found, is negative 7. So it's 11 plus 40 times negative 7. So when you reduce that, the 41st term in this sequence should be negative 269. Now, sometimes you're not going to be given the first part of the sequence. Sometimes you may know 2 terms of an arithmetic sequence that are not in consecutive order or at the beginning. So well, let's define this first before I ask you for it. Okay, we'll say the terms between the terms between two non-consecutive terms of an arithmetic sequence. The terms between two non-consecutive terms, so that just means two terms not next to each other, not a sub 1 and a sub 2. It might be like a sub 1 and a sub 10. They are called arithmetic means. Arithmetic means. So using that vocabulary, you might get to a question like this. Form an arithmetic sequence. Form an arithmetic sequence that has 6 arithmetic means. That has 6 arithmetic means between -12 and 23. So we don't know if -12 is, well, even though we don't know if this is the first number of a big sequence, if I'm giving you this snapshot, then it is appropriate to say that, first of all, let's talk about how many terms are in our snapshot of a sequence. If there are 6 arithmetic means between these two numbers, that means there are 8 total, right? Because these two would be 1 and 2, and then there are 6 in between. So that means n is equal to 8. There are 8 total terms in the sequence. We know that our last term is 23. So of those 8, n sub 8 is 23. And of those 8, n sub 1, the first term is -12. Okay, so again, if we use my formula up here that we did earlier, where the nth term is found by doing this, well, then I can say a sub n is equal to a sub 1 plus n minus 1 times d. Basically, if I want to figure out what the 6 terms in the middle are, I just need to figure out what d is. If I know the difference, then I can count, okay, if the difference is 1, I just add 1 each time from -12 until I get all the way up to 23. But I don't know the common difference. That's what we're going to solve for. So if we use that formula, though, we can kind of work backwards. A sub n, the nth term in this case is a sub 8. Or sorry, n sub 8. Well, I wrote n. I guess technically these are just a's. A sub 8, a sub 1. Okay, so a sub 8 will be 23 is equal to the first term, -12, plus, again, n minus 1. N for us is 8 minus 1. And then we don't know d. Okay, so then you get 23 equals -12 plus 8 minus 1 is 7d. So add 12 to both sides. So this could be 35 equals 7d, giving us a common difference of 5. Okay, so that's all we needed. If I know my starting term is -12, I know there are 6 arithmetic means. 1, 2, 3, 4, 5, 6 between -12 and our final number in that sequence, which is 23. Now that I know that the common difference is 5, then I simply will just add 5 each time. -12 plus 5 is -7. -7 plus 5 is -2, plus 5 is 3, plus 5 is 8, plus 5 is 13, plus 5 is 18, plus 5, I should get my final answer of 23. So this would be my answer. That would be an arithmetic sequence that has 6 arithmetic means between -12 and 23. And you can like logic your way through that, but guys, you logicking your way through that to figure out the distance between -12 and 23, and then, you know, what the average kind of would be throughout. That is exactly what this equation is doing. So even if you do something similar to this, as long as you're showing me what you're doing in order to find that math, that's fine by me. Okay, so that's the first part of this section. That dealt with sequences. The next part is about a series. An arithmetic series is the indicated sum. The indicated sum of the terms is the indicated sum of the terms of an arithmetic sequence. So, very, very simple definition. You take your arithmetic sequence, instead of just listing out your numbers, the series just takes the sum of all of those numbers. So, for example, if I tell you that I have a sequence with the following numbers: 2, 5, 8, 11, and 14. If I wanted you to find the corresponding series, you literally just add those terms together. 2 plus 5 plus 8 plus 11 plus 14, which is equal to 40. So that's the difference between an arithmetic sequence and the arithmetic series. Now, of course, I have a formula for this as well, because if I asked you for, find the sum of the first 1,000 terms of this, you're not going to literally type in all those numbers in the calculator. So the sum of finite arithmetic series, meaning it ends, right? We can't add a series that continues on into infinity. So the idea is it has to be finite. In order to find the sum, you use the formula S sub n, so S standing for sum, is equal to n divided by 2 times A1 plus A sub n. This is the other big takeaway from today. The sum of a finite arithmetic series is denoted by this equation. So let's do our last example. I want you to find the sum of the first 32 terms in the series. Negative 12 minus 6 minus 0, ... So find the sum of the first 32 terms in this series. Again, series, notice I'm not just listing terms by a comma. I'm actually, having a string of numbers being added, or in this case, subtracted. So if I want to use this formula, let's fill in what I know. S sub n, in this case, n is 32. Okay, so S sub 32 would equal n over 2, so it would be 32 over 2, times A sub 1, so the first term in this series is negative 12, plus A sub n. A sub n in this case is 32. I have no idea what the 32nd term is of this series. So before I can find the sum of the series, I need to backtrack a second, and I need to use my formula that we did earlier, which is just how you're able to find a particular number of the sequence or of the series. So A sub n is equal to A sub 1 plus n minus 1 times d. Because I know, so A sub, I'm trying to find 32. I know my first term, A sub 1 is negative 12, plus n, again, the number I'm looking for is 32 minus 1 times d. Again, d is the common difference. So to get from negative 12 to minus 6, that's subtracting 6. Negative 6 minus 6 is how I got 0. So d in this case is negative 6. So when I, subtract these all and add them, or multiply them and add them appropriately, 32 minus 1 is 31. 31 times negative 6 plus negative 12 should give me a 32nd term of negative 198. Now that I know the 32nd term, I'm going to plug this number back into the summation, the sum of the series. So S sub 32 is equal to 32 over 2 is 16 times negative 12 plus a sub 32 is negative 198. So let's see, negative 12 plus negative 198 will be 16 times negative 210, which means the sum of the first 32 terms in the series that I literally only knew 3 numbers at the beginning of would be negative 3,360. If I were to literally write out all the next, it'd be 29 terms because this is already 3, right? 29, 30, 32. And then added them all together, I would get negative 3,360 if I continued the pattern of subtracting 6 each time and then adding all of those numbers together. So there's another video that kind of goes along with this. This one's dealing with arithmetic sequences in series. The next one is dealing with geometric sequences in series. You will watch that video tomorrow, but just so that you know for now, let's talk about your homework. The thing about this homework, it is due Friday. So we have such a strange week with EOC testing, and Friday is May the, 6, 7, 8, 9, 10, 11, I believe. May 11th. Such a crazy week with EOCs and the start of AP testing that I'm really trying to be mindful of that. So your first and only homework from the week is going to come from 2 sections, 12.1 and 12.2. The first one's going to come from page 763, and it's going to be numbers 23 through 40 and 44 through 46. 23 through 40, 44 through 46. This is all, by the way, unless I specify odds or evens or something like that, you need to assume that you're doing them all. So those all together is 21 total. The next one comes from 12.2, which starts on page 771. It also goes to 772, which these numbers are a lot more kind of pick and choose. They're not chunks. 19 through 24, 26 through 27, 30, 32, 34 through 35, 38, and 39. So if you count all of these together, it's going to be 35 total. Again, not due until Friday. At this point, you know how to do the first 21 tomorrow, or you can even look at the textbook and start getting ahead if you'd like to figure out how to do the ones from the second section. So this is the homework for this week.